In this unit, we're going to look at exponential functions. In this lesson, we're going to look at exponential regressions.
All right, hi everybody. So in this lesson, we're going to take a look at exponential regression, okay? And regression really is just a fancy word for line of best fit, okay? But this time around, what we're going to do here is we're not going to eyeball it. We're not going to plot the points and then kind of use our best guess to figure out what the line is that we're going to use. There are programs that are on our calculators that are designed specifically to do this, to find the line of best fit. And there are programs that we trust, or techniques, we should say, that allow us to create these lines that try to follow the data as closely in general as possible here. So, like it says here, sometimes we're given a table of data with two sets of data. Okay, so basically we're talking about your X and your Y here. And if the points appear to follow a pattern, okay, and that could be linear, quadratic, exponential, logarithmic, whatever, then we use a technique called regression. Okay, we're going to regress to the line, okay, the line of best fit, used to fit the possible curve of the data. And then we can determine, well, we can make predictions based on that equation, right? Like sometimes it can be hard if you just got all these little dots there that you're looking at to make a prediction from that pattern. But if you've got a line that you know does a really good job of representing the data, then we can use the line to make predictions. And the nice thing about that is if we're using a technique that's shared by everybody, okay, if we're all using, for example, the same program to get that line of best fit, then we're going to agree. Okay, all of our results will be kind of universal there. So on our calculator here, what we're going to do here to determine the exponential regression, first of all, we're going to press the stat button. Okay, and that's going to open up a screen that looks like what you're seeing right there. And first of all, we want to enter in our data. So we got to go into edit. So we press edit here, and we're going to put our X values here in list 1, or Y values in list 2. But quite honestly, even if you do that differently, even if you realize you've entered the data in backwards there, the calculator gives you some freedom to fix that, okay? When we're looking at the actual calculator here, we'll talk about what to do to clear out data that's already in there, because if you've got numbers that are in there, you want to clear them out before you move on. Once that's done, we're going to quit out of there. Then we're going to go back into the stat menu. We're going to go into calc. And what you're seeing there is a list of possible regression equations that it can find here. For our purposes here, we are looking for the exponential regression, and that's going to be choice 0. Then what we're going to do is the calculator is going to give us this. Now, some of our calculators are going to look a little bit different. The calculator that I'm going to use in just a couple of minutes here is actually going to write this out a little differently than we're seeing right here, but it amounts to the same thing. I have to tell it that the X list is list 1 and the Y list is list 2. So this is what I'm saying here, X, comma, Y. Okay. Then I press enter here, and it's going to tell me what the equation is supposed to look like. And then from there, I can put that into Y1 so I can graph it by going into Y1, and then you press the vars button, go down to number 5, because number 5 is going to be statistics. And everybody, I'm going to walk through this in just a moment here, so you'll get to see this all happen. Then we go to the EQ menu, and that is going to plot that's going to take the regression equation and put it into Y1. And then 2 here, we're going to adjust the window settings. But what we're going to do here to start off with, or at least what I want to do with this, is I'm going to turn my plot on. So I'm going to press second, okay, and I think it's actually second Y equals. And I'm going to enter on plot 1. Okay, I'm going to press enter, and I'm going to turn it on. And then from there, I'm going to press zoom, and I'm going to press zoom number 9. And what that's going to do is that's going to give me window settings that approximate the data that I've entered in quite well. And from there, I'll adjust those window settings to fit whatever question it is that I'm being asked, because oftentimes the question that I'm going to ask isn't going to quite fall into the window settings that the calculator chooses for me there. At the end here, to determine whether an equation represents a growth rate or a rate of decrease, we simply got to look at the following here. So we're going to look at B, And if that base there is greater than 1, then it's increasing. And to find the rate of growth, you're going to subtract 1. Now, if that doesn't make sense, I'll show you an example in just a moment here. And if the value of b is between 0 and 1, remember that represents a decreasing function. And again, to get the rate of decrease, we're going to subtract 1, and then the answer is going to be negative, indicating a loss here. So what on earth are we talking about? Well, let's just take a quick look at a couple of examples here. Okay, so for example, for these first two, we are looking at increase because in both of these cases, the b value is greater than 1. Okay, now in this first case here, that 1.03, what that represents is 100% plus, well, what is 0.03 as a percent? If I move the decimal over, that's going to be 3%. So 100% means that I've maintained the value that I'm at, and then I've increased by 3%. So that is the growth rate. Here, this is 100%, okay, plus, well, 0.025, that's going to be 2.5% here. So that's a growth rate of 2.5%. It's 2.5% larger than maintaining at 100%. On this this next column over here, we're looking at decrease or decay. So my b value here is 0.98. Now, every time I'm doing this, I'm comparing this to 100. So for these ones here, I want to know how much over 100% is this. Okay. Here, I want to know how much below 100% is this. So for this one right here at 0.98, if you were to subtract 1 from it, you would get negative 0.02. Okay, so 0.98 minus 1, you're going to get negative 0.02 here. That represents to me a 2% loss. Okay, we're 2% lower than 100%. Here, if I take my 80% and I subtract 1, I'm going to get negative 0.2. And this represents a 20% loss. Basically, whatever's inside here, whatever's inside those parentheses, whatever the base of the power is, that represents the percentage that you get to keep. Okay, so in the first one here, in these first columns, I got to keep here 103%. Here it was 102.5%. But here, for this one, I only get to keep 98%, and here I only get to keep 80% of what I started with. Okay, now let's take a look at some questions, and we're going to start to pull out that calculator and do some regression calculations with it. So we read in this question, for each table of values, identify if it is exponential growth or exponential decay. Okay, so those are the two that we're going to differentiate between here, and determine the exponential regression equation and the rate of increase or decrease. Okay, so there we go here. So what we've got here is, for this first one, I go 1, 6, 2, 18. Well, okay, notice that the values are growing here. So, I mean, this is clearly going to be growth. Whereas the second one here, I got 1, 200, 2, 100, 3, 50. Okay, this is clearly decay. The values are getting smaller. Okay, well, now what we want to do here is we're going to go to the calculator here, and we're going to plug this information. We're going to do this one at a time here, and then I'll come back and fill in the information here. But we're going to go through and get the calculator to tell us what the regression equation is. Okay, so now to enter in the data here, what we're going to do is we're going to press the Stat button, okay, and enter on Edit so that we get to the window here where the lists are here. So our X values here from our chart are going to be 1, 2, 3, 4, 5. And then we move over to the L2 here, and it's 6, 18, 54, 162, and 486. Now, once the data is all entered in here, for me to get the equation, first of all, I'm going to quit and press second mode to get out of there. And now I'm going to go back into my stat. Okay, so Stat button, over to Calc here, and I'm going to go down, 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 down. Okay, what we want here is exponential regression. So 0 here, press enter. Now, my calculator here is anticipating that I want the X list to be list 1, the Y list to be list 2. And again, I don't want, if you've got anything here, we don't want anything in the frequency list. That's telling us whether or not these objects are repeated more frequently than what I'm seeing there. And the answer is no in this case here. So I'm just going to go down to calculate. It does give me the opportunity to tell the calculator where to store the regression equation. But for right now, because I know some of the calculators are going to be a little different, we're just going to move over that. We're going to go down to calculate, press enter. Okay. And it gives you the equation here. It tells us that the equation is going to be in the form y equals a times b to the power of x. And then it tells us that a is going to equal 2 and that b is going to equal 3. So from there, we're going to go back to the question. We're going to answer all the questions based on that formula or that expression right there. So we got here that our equation was y equal 2 multiplied by 3 to the x. So the value of b in this case was 3. Now, let's talk about that because the question says, what's the rate of increase or decrease here? Well, 3 in this particular case here, now remember in like that previous one here, we were looking at this, trying to interpret this as a percentage here. This is, that 3 there represents 300% of what we were initially, what we initially had here. This is a growth of 3 times, okay, the original value. Every time we hit our period, every time we go up a step here, we're 3 times the original, or actually I shouldn't say the original. That is really not what I meant to say there. This is going to be 3 times the previous. Or if you want to think of it like this, that is 1 plus 2, which basically means 200% growth. Okay, we are growing 200% beyond where we were to start off with. So this is definitely growth because the base of that power is larger than 1 here. Our A value was 2. And remember back to the properties or characteristics of the graph here, that means that the y-intercept of that graph is also going to be 2. Okay, now let's take a look at this next problem here. Okay, we've already talked about, we can already see that it's decay. Now let's go to the calculator and plug in those values and see what we get for that regression equation. Okay, so in this case right here, we're going to go back into our stat, press stat, back into edit, and oh, there's data in there. Now, I'm not too upset about my L1 data because when I look at my list there, it's exactly the same as what I've got there, but I've got this 6, 18, 54, and so on in my L2, and I don't want that. So to get rid of all that data, I could clear them out or delete them out term by term here, but what I can do is go up to the L2. Now, don't press the delete button. That's going to get rid of the list, and we don't want to do that. What we want to do is press clear on the right-hand side of the calculator there, and the calculator gives us a moment to say, are you sure? And then we press enter to get rid of it. So clear and then enter on the name of the list gets rid of the data there. And then 200, enter 100, 50, 25, 25, and then 12.5. Okay, we list that in there. Then we're going to quit to get out. And then once again, I need to go back into the stat here. Okay, and then what I want to do here is go over to the calc menu. And again, we're going to go down to that exponential regression. So down to 0. I could have just pressed 0 here, by the way. But anyway, down to 0. It's still going to list 1 and list 2. That's what I want. Okay, I'm going to go right down to calculate. And you can see really quickly that exp reg L1, L2. And there we go. So our A value here is 400. And our B value here is 0.5, or the fraction 1/2. So now let's go back and put that information in our answer sheet there. All right, so the equation we got here was 400 is multiplied by 1/2 to the x here. Now this one is clearly decay. And notice that my base here, my B, was 1/2, which means I have 1/2 of what I had before. Okay, that's 1/2 left over here. And so essentially, this means I have lost 50% here. So I have 50% loss here. Okay, so or a 50% rate of decrease here. So this is definitely decay. Okay, now the value of A there is going to be 400. And just like before with the characteristics of the graph, that means that my y-intercept, if I was to plot this, is going to be 400. Okay, now let's take a look at another one. All right, so now this next question says, use the following data to answer the questions below. So years and the value of a ring here. Okay, now you're going to see in a lot of these questions, it's going to be more common than not to start with a zero here. Okay, and that's just the way we're going to do most of these things here. And in fact, even when the table is set up so it's not starting at zero, sometimes the smarter thing to do is just to make it scale everything down so it starts at zero and works its way up here. So we can see that the value of the ring is increasing as we go from year to year, okay? But what we want to do is come up with an exponential regression equation so we can answer a couple of those questions here. So let's go to the calculator right now and have a look. Okay, so just like before, the first thing we're going to do here is we're going to enter our data in through statistics. And we're going to go and press enter and edit. And I'm going to have data in there already from a previous question here. So remember how I deal with that. I go up to the name, press clear, and then enter. And then even over here, the data isn't quite the same. So I'm just going to go up here to list one, press clear, and then press enter to clear that all up here. Now I can come down and enter the data, which was going to be 0, 1, 2, and 3. Those will be the years. And then the value will be 9,600, 9,960, 10,344, and 10,752. So good. So now all the data is entered in there. And the question was asking for a regression equation. Okay, so let's quit out of here. And now I want to press stat. And then I go over to the calc menu for this. And this time, instead of going down, I'm going to press the 0 here because 0 gets me right to the exponential regression. And list 1 is good. List 2 is good. I'm going to go down. I don't really need to worry about any of the rest of that for right now. And I'm going to press enter. Okay, now it's a little bit more complicated here. Okay, so we've got a times b to the x, which is fine. I was totally expecting it to look like that. 9595.43. So we'll go maybe to the nearest 100th there for both of these. Actually, you know what? For the b value, I am actually going to take it to 3 decimal places to the nearest thousandth here. So 1.0385. So I'm going to put that as 1.039. Okay, we're going to talk about it like that. Okay, so that's the information I need to answer the first couple of questions. So let's go back and answer those questions there. So we got that our regression equation was y equals 9595.43 multiplied by 1.039 to the x here. So the value of b here, not as approximate, but it's a good approximation, going to the thousandth place here, is 1.039, which means, remember that 1 kind of represents 100%. It represents what I'm starting with. So I'm 3.9% larger than that 1. So that means a growth of 3.9%. Okay, so now look at the next question. It says, determine the value of the ring in the 10th year. So what that means here is I'm actually going to go up to my equation here. I'm going to plug 10 in for the x. Now, I want to show you how you might do that graphically. So let's go back to the calculator for a moment. Okay. So we're going to use this equation now to figure out what the value of the ring is going to be in the 10th year. Now, there are a couple of ways that we can do this, but one way to do this would be to do it graphically. And I want to make sure that you catch how to do this. So I want to graph this material here. So I'm going to come into my y1, and I want to put that equation there, but I don't want to look at it, write it down, and copy it in here. It turns out the calculator has memorized all of that, okay? So what I'm going to do here is I'm going to press the vars button right here, and that's going to take me to a menu here. And what I want to do is I want to go down. I'm doing some statistical work here with these lists. So I'm going to go down to statistics. And EQ is where it holds all of the parts of the equation here. So we're going to go over to EQ. And the very first thing that it holds there is this regression equation variable. That represents the entire equation that we just found a moment ago. So if I press enter here, it's going to put the equation there the way I want it. Now, I could very easily just graph this right now, and you can see that the calculator is thinking up here, thinking. I'm not seeing anything, but it's thinking, doing a lot of thinking here, and nothing happens. I'm not seeing anything here. Well, it's because my window settings aren't aren't set up to see the data here. So the way I can get around that is by going second, stat plot. So the calculator can be told to look at the statistical data here and adjust the settings to account for that. So I'm going to go press enter to get on there, and I'm going to press enter to turn that stat plot on. I like the fact that this first stat type is highlighted. That's a scatter plot. It's just the little dots. It's got other ones that it can use here, but this is the one I want. The X list is list 1. The Y list is list 2. That's important when coming up with the window settings. And the rest of that isn't really all that important. You can make that whatever you want. But now what I'm going to do is I'm going to press zoom, and all the way at the bottom here is this zoom stat. That's the one that I want, because that'll tell the calculator to look at the window settings, look at the statistical data in list 1 and list 2 and adjust the window settings to account for that. So there we go. So now I can see the data, and I'm seeing my line go through the data. Now, I want to know what the value of the ring is in the 10th year. So, but I got to go to my window here. Notice that it only has a maximum, the X coordinate has only got a maximum of 3.3. Well, that's not useful to me. I need that to go to at least 10. So let's make it go to 12 here. See what happens when I press graph. It's a really, really steep graph now. And it goes off the screen. Calculator is thinking. Okay, it'll be done. Now, interesting thing here. It's going to reach 10,000 way, way up here. It doesn't matter that the answer is above the screen. If I now press second, trace, and I'm in this menu here where I can do stuff with the graph here. If I press enter on value and simply tell it, I want to know what happens in the 10th year, press enter, the calculator has no problems with that. It has no, in fact, here's my answer here, that $14,000.64 here, okay? Calculator has no problems finding something if it's above the screen, but if that answer was to the left or to the right of the screen, it wouldn't be able to find it, okay? So, I mean, this isn't ideal because I can't see where that's happening, but because it's above the screen, I'm okay. So let's go back and put our answer in. Okay, so our answer here, we just found was $14,000.64, although probably didn't really need that. Probably really only needed to say it was worth $14,000 here. Next question asks, in what year will the ring reach $13,000? So now I'm giving you a y coordinate, and I'm asking you for that x value here. So again, this is a calculator problem, and one that you can do quite nicely graphically, which is why I chose to do even that first question. We didn't have to do C graphically. We could have just written out the equation and plugged a 10 in, okay, for the x here and evaluated it. But I want you to see how we do this graphically here. So anyway, let's go back to the calculator and see if we can figure out when the ring first reaches 13,000. Okay, so in this case here, because we were given that y coordinate, I'm going to go back into y equals. I'll go down to y2, and this is where we'll enter that 13,000. Now, I know I'm not going to be able to see that. If I go to my window settings here, my maximum window setting here for the Y max is 10,947. I need that to be larger than 13 if I'm going to see where this is occurring. So let's make that 15,000. Okay, and for the time being, I'm not going to adjust the X max there. That's fine. I'll just leave it like that. Press graph. And here we go. So we see it curving up there. And as soon as it's done, we're going to get that 13,000 going across. And so what we're interested in is this point of intersection right there, specifically the X coordinate. So second trace gets us into that menu that we're interested in. And we are looking for the intersection of those two. Now, it asks us for the first curve. Basically, it's saying, am I on the first curve? And the reason why it's saying that, asking that, I should say, is that you could have all sorts of different graphs drawn here. It just needs to know which one it is. So yes, it's on the first curve. Then it jumps to Y2 there. Is this the second curve? Yes, it is. Is it okay if I guess this value right here? Now, you can just press enter to get past that. I suspect everything that we do, it won't matter what that guess is. Press enter, and it's going to jump us to that point there. And so we get 8.037, okay, is the value that gets. We already knew it was going to be 13,000 because we plugged that in as the y coordinate. So it's that 8.037 that's significant. So let's go back and put that in our sheet there. So like we said, we got this 8.037 here. And now it says, in what year did that occur? Well, okay, look at the way this is working here. It probably makes sense for us to round to the nearest whole. And in fact, in a lot of the cases here, most of the cases that we're working with, that's really what we want you to do anyway, is round to the nearest whole. So we're going to say the 8th year here. And that does make sense, even based on the way we're starting this. If we're starting at 0 here, basically 0 up to 0.9 is going to be the first year, and then 1 up to 1.9 sort of thing is going to be that first year. Sorry, the 0th year, I guess, is the way to do it. We're going to round down there. Anyway, that probably sounded stupid the way I just said that here. I didn't mean to confuse you by that, but just as a rule of thumb, the questions are typically going to be asked so that you either they're going to tell you exactly what to round it to, or they're going to expect you're going to round it to the nearest whole. Okay, that said, let's take a look at this next question here. What's the domain and range of the information above here? Well, and actually, we're going to ask you that in two ways here, for two different parts of this question. So first of all, this domain and range question has to do with the data that's immediately above here. Now, notice that what the graph is doing is it's going from, the table is going from 0 to 3, and from 9,600 to 10,752. The expectation here is not that you're being overly critical about this, okay? This is mostly just like a knowledge thing. So if you were looking at the information above here, our domain is going to go from 0 out to 3, okay? Data starts at 0, ends at 3. That's what we're seeing in that table here. The range, our y value here, starts at 9,600, and it goes up to 10,752. Okay, now what happens if we keep it for 25 years? How does that affect our domain and our range here? Well, when we say that, we've already given you the domain. We want this to go from 0 out to 25. Okay, and sorry, you'll notice that I'm not right now. I'm not filling in this chart here because we've been doing this graphically. I've been going to the calculator, and you've seen the graphs go on there. So for the range, that's going to be 9,600 up to, oh, well, you know what? I don't know. I don't know what it is. We got to go up to 25 years. Okay, so now we got to go back to the calculator and see if we can find that the value at the 25-year mark. Okay, so we're back at the calculator here. Now, we know we've got that formula in there. I don't really need that 13,000 anymore, so I'll just go down there and get rid of it. But let's go back up to our window settings here. I need to know, or we've adjusted this question here so that we're going from 0 to 25. So really what I need to do is I need to make this X max a little bit bigger than 12. I need to make it, a bit bigger than 25 even. So I'm going to go out to 30. I'm not entirely sure what that's going to do for our max here, but you know what? I tell you what, let's make this go up to 25,000. I'm just guessing at this. I don't really know. Let's press graph and let's see what happens. Okay, so here we go. Well, I don't even think that 25,000 is going to be high enough for us to figure out where the 25,000, or sorry, where the year 25 is. So like if I go into second trace, I just need to figure out what the value is, the y value is when the x value is 25. But I don't even think that's going to show up on the graph here. Oh, it did, just barely. I thought it was going to be off here. Okay, so the y coordinate that we get here is 24,675.88. Okay, so that's what we're looking for here. That is going to end up being the limit on that, the upper limit on the range. So let's go back to the question. And there we go. It was 24,670. You know what? Let's round that to the nearest dollar there. So because it was rounded like that in the chart here, so we'll just do it like that. So 24,676. Okay, good. Let's go and take a look at another problem. So this question here says, Joe purchased a car and kept track of its black book value as shown. Starting at year 0, and we were talking about that before, we typically do that here. We go up to year 4, and we have the value there. Very first question is going to be to write the the exponential regression equation, and then what's the rate of depreciation. So those two are going to go together. Okay, well, let's go to the calculator and let's enter that data in and find the regression equation. Okay, so we got a brand new question here, so we got to put new data in. So stat, press enter on edit. Okay, so we got some old data there. Now, nice thing is about the list 1 here is actually it's basically what I wanted it to be. I want it to be 0, 1, 2, 3, 4, so just have to add a 4 to it. But list 2 is old data here. So we're going to go back up here. Oops. We're going to go back up and we're going to delete that. So clear and then enter. So now I can enter 27,650. Okay, 21,912. 18,200. Sorry, 100. There we go. 16,609 and 15,162. So there we go. All the values are entered there. Now I'm going to quit out of there. Then we go back into our stat menu over to our calc menu. And remember, it's 0. We're looking for the exponential regression. So we go to 0. Everything looks good. List 1, list 2. Not going to worry about the frequency list or storing it in the regression, storing the regression equation. We're just going to press enter and calculate, and boom, there we go. Okay, and so we've got 26,130.81, okay, as our A value and our B value here. And just like I did before, I'm going to go to the nearest thousandth here, so 0.863. Okay, so let's go back and enter that information in. Okay, so our regression equation that we saw was going to be 26,130.81 multiplied by 0.863 to the x. And now the rate of depreciation, remember, that's the rate, the amount that we're losing. Okay, so what we see here is always what we have left. The rate of depreciation is what we've lost. So what have we lost here? Well, the easiest way to do that is to take that 0.863 and subtract 1. And then you're going to see here, we're going to get this negative value here. We have lost 13.7%. Okay, so that's our rate of depreciation. So question C says, estimate the number of years it will take for the value to be less than 7,000. So basically, we want to know how long it takes to get to 7,000. Anything beyond that, we're going to be less. So, okay, that's a y coordinate. And again, like I said before here, you notice that I'm not really graphing anything over here because I'm using the calculator to do it. This over here was just a tool to help you plot that data, but I'm going to plot it on the calculator here in just a moment. In fact, let's go right now. Okay, so this is that regression equation that we just found. What we want to do is put this into the calculator so we can graph here. So we're going to go y equals. There's already an old equation there, so let's just delete that. And now to put that equation in here, remember it's vars, variables. We're going to go down to statistics. That's number 5. And then over to the equation menu here. And the very first option is that regression equation. You'll notice up here that the plot 1 is highlighted. That's because the plot 1 is still turned on. And actually, I'm okay with that. I want it to look like that. Because now that I've got the regression equation in Y1, if I simply press zoom and then number 9 for zoom statistics, it's going to give me a window settings that match the data that I just entered in there. Okay, and so there we go. Now, I want to evaluate this. I wanted to figure this out. When does it hit 7,000? So we're going to put 7,000 in here as a y coordinate. I am not 100% sure if my window settings are going to allow that. So take a look at my y min. Okay, notice that my y min is 13,000 watts, substantially above what I want. I'll tell you what, let's just put a 0 down there as our y min. Now, I suspect that is going to happen a little ways beyond 4.4 as my x max. So let's just put 10, just a nice round number there, 10, and just see what happens there. So I press graph. That should do it. I hope. It's dropping down. Okay, I'm hoping that 7. There we go. Yep, it does, right there. So we are getting a good point of intersection there. Wonderful. So second trace to get into that menu, that calculation menu, we want to do number 5, intersect. So the calculator is asking, am I on the first function? Yep, press enter. Did I jump to the second function? Yep, press enter. Is it okay to guess 4.8 as a starting guess? Sure, sounds good. And then it jumps over to 8.9. Okay, 8.9. So let's go back and we'll enter that in. So we got here that the estimated number of years was going to be 8.9. And so I tell you what, just like I was saying before here, we're just going to round this to the nearest value there. We don't want to make this overly complicated. So 9 years. Now, the last question here for this part says, how much will it be worth in 10 years at this rate? So now we want to go back to the calculator and plug in that 10 years and see what the value is. Okay, so here's our window after the last question when we graphed it. Actually, let's go back up to the window because it just occurred to me that I may have already set myself up nicely for this. Yeah, I've already given myself the X max is 10, and that's what I needed. I needed to have the window set up so that I can at least get that value in there. So if I go back to the graph and second trace, and we're going to do value here, and this time I'm going to enter in 10. And I got to watch this because I've got two functions here. And notice I can jump from one function to the other just by pressing the up or down arrow keys, but I want the blue function there, the lower one. And when X is 10, I've got $5,955.75 or 76 cents. So that's the answer that we were looking for. And it was nice that my window settings just barely let me have that. Had that been had it asked for 11 years, I would have had to have gone further over. I'd have to adjust my window settings because the calculator wouldn't have looked at that. So anyway, let's take a quick look here and put that back into the question. And so there we go. That was $5,955.76. Good. Okay, now let's look at the next question. Okay, so this next question here says the data shows global population in billions over a 40-year period. So 1970, and our population numbers here are going to be in the billions. Then we go up to 210 here. Now, what we're going to do here, though, is I'm not going to enter in 1,970, 1,980, and so on and so forth as our X values here. What we're going to do is we're going to scale this down. Let's let this be 0. This is our starting point. And then they're going up by 10, so we'll be consistent with that. So this will make this 10, 20, 30, 40, whoops, 40. Up. And those will be the numbers that we'll enter in there. And then we'll interpret our data based on those values here. It just keeps the window settings from getting out of control, and our numbers, particularly our numbers in the regression equation, it sort of keeps them a little bit more manageable. So let's go to the calculator and start entering this stuff in. Okay, so just like before, let's go enter our data into stat. We'll press enter on edit to get in there. And I'm going to want to clean up both of those. So go up to the menu, the name there, clear enter, go over, clear enter. And now 0, 10, 20, 30, 40. And then over, and this will be 3.91, 4.52, 5.22, 6.03, and 6.97. Okay, so there's our data in there. So just like before, just like we've done kind of over and over again, let's figure out what the exponential regression is. So stat, over to calc, 0, list 1, list 2. And there we go. So our A value here is 3.91. Okay. And our B value is 1.0115. Okay. So we'll take that to the nearest thousandth there. So 1.015. Okay. Let's put that information into our answer sheet. Okay. So the calculator told us that the equation was going to be 3.91 multiplied by 1.015 to the x. And notice that our B value here is a little bit over 1. So it's a little bit more than 100%. How much more? Well, that's 1.5% beyond 100%. Okay, so that's a growth rate of 1.5%. So now we're going to figure out the population in 2020. Now, bear in mind at 2020, that's going to be where my X value here is going to be equal to 50. Okay. And then we're going to figure out when it will reach the population of 10 billion. I tell you what, we'll do both of those. We'll go to the calculator. We'll do both of those kind of in quick succession here. So let's go to the calculator. Okay. So here's our regression equation. Now we need to put it back into y equals. We've already got some data in there. So let's clear it. Clear this one out. Okay, now we're going to put our regression equation in here. Remember how we do that? We press our vars button for variables. We're going to go down to 5 statistics, over to their equation menu there, and regression equation is the one we want. So that puts the equation right down there. Because I have my stat plot turned on, and remember I do that by going second y equals, okay, and I can get in there and turn that on. When I press zoom number 9, the calculator is going to look at the data in list 1 and list 2 and pick an appropriate window settings for me. And so there I go. Now we want to figure out what the value is at 2020 here. I got to look at my window and make sure 2020 is going to show up in there. Okay, so my X max there is 44. Oh, sorry, 20 there. I meant 50. I said 20. I meant 50. Yeah. Okay, I'm going to make that equal to 60 here. Okay, I just need to go like one more 10 value beyond my chart here. Sorry, I don't know why I was saying, oh, I know I was saying 20 because it wanted 2020. But our chart started a bit earlier. Sorry about that. I don't know why that kind of slipped past my mind here. So let's press graph. I know that I'm not going to be able to see the point, okay, where the X coordinate is 50. Or if I do, it's just barely here. But that's okay, as long as it's above the graph and not to the left or the right of it. So I'm going to press second, trace. I'm going to choose value here because I know what the value is supposed to be. I want that to be 50. And it is just slightly off the graph there. And I'm getting that my population is going to be 8.05. Okay, 8.05. And actually everything's to the nearest hundredth there. So that makes sense here. So 8.05. Now let's take a quick look because we knew that the next question was how much it would take to get to 10 billion here. So now what I'm going to do is go y equals. We'll come down here and we'll plug 10 into this. I suspect that if I look at my window settings, my y coordinate's not going to be large enough. And it's not. So we're going to go down here and make our y max a little bit larger. Let's go up to 12, a little bit beyond 10 so I can see the point of intersection. Press graph. And you know, I'm not too sure that I'm going to be able to see this on my graph. I might be able to, but it doesn't look like I will. Okay, so I can see right now that my point of intersection is going to be slightly to the right of my graph. So right now I won't be able to find it. So I have to press window and I have to make my X max a little bit bigger. Let's maybe make that 80. Hopefully that, if I go another 20 up here, that'll be enough so that I can clearly see that point of intersection. Okay, yeah, that should be no problem there. We come along, and we are going to be looking for that point right there. So second trace, we're looking for the intersect. Am I on the first curve? Yep. Did I jump to the second curve? Yep. Can I guess 38? Sure. And I get 65.00. So 65. In what year will it happen? Year 65. So let's go now. Years. Sorry. Now I got to interpret that. We're going to come back. We got to talk about that in just a moment here. Let's go back to the answer sheet. Okay, so when we worked through that question here, we figured out that the population in 2020 would be 8.05 billion. And then in what year would it reach 10 billion? Well, we got here that X was going to equal 65. Now take a look at that. 2020, the year 2020 corresponded to X equal to 50. So 65 is going to have to correspond with the year 2035. That's what they're asking for here. So we need to be able to interpret a little bit how our numbering system, okay, how our numbering system here, the 0 up to 40, is going to affect that year number when we get that final answer. Just takes a little bit of kind of thinking about that, and we're good to go. Okay, let's take a look at the next question. Okay, This one right here says the graph below shows the growth in square millimeters of a rare fungus, F, in a petri dish after each day T. The equation of the function is, so we just have to match the equation of the function to what we're seeing here. Now, remember that the A value corresponds to the y-intercept. So, and the y-intercept here is clearly 2,000. So it can't be A, it can't be C. So it's got to be either B or F here. So the question is, what kind of growth do we have? Well, what you might want to do is just go to your calculator here and enter, let's just say 4. 4 works out nicely because it looks like 4, well, they give us the number there. Actually, they give us the number at all of these ones here, but 4 is nice here. If you plug 4 into this, if you go to your calculator and enter 2,000, and let's just plug in 2.25 to the 4, you're going to notice right away, hey, you do not get 10,125. You get a number that's substantially bigger. Okay, so that means by default it must be D. But if you go in and check that anyway, 1.5 to the power 4, yeah, you will get 10,125. And so as a result, yeah, the answer to that is D. Good. Okay, let's take a look at one more question. So this question here says that we're given a list of the closing prices for the Nasdaq stock index prices at the end of February. Whoops. Oh yeah, I forgot. At the end of February. Oops. So here we go. And then we're going to get some questions on there. Let's go through and enter that into the calculator. But remember, we're going to start with 0 here. Now, look how the numbers are working here. If we let 1992 be 0, notice it goes up by 2's here. So maybe we should go up by 2's here just to make this a little bit easier to work out later on here. So 0, 2, 4, 6, 8. We're going to work it up like that. Okay. Probably going to have to adjust our answer for something like 2017 here, but you know what? That should at least be a little bit easier for us to work with. So let's enter the data in like that and see what we get. Okay, so one more time here, we're going to go into Stat, press Enter for edit, and we're going to enter in our data here. So first of all, we got to clear out what's there. We go over, up, clear out. Oops, sorry. I got to clear out what's there. And then remember what we're going to do with this one. Just going to enter 0, 2, 4, 6, 8. 0, 2, 4, 6. Yeah, 0, 4, 2, 4, 6, 8. Here we go. And then we'll go over here and enter those numbers in. So 633, 793, 1100. Whoops. 1100. 1771 and 4696. Okay, so we'll quit and we're going to do our regression equation. So we press Stat. Okay, over to the Calc menu. We're going to go down to 0. That's our exponential regression. Enter, 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 enter. And there we go. So our equation is going to be 518.18. And then once again, we're going to take this to the nearest thousandth, so 1.272. Okay, so let's enter that into our answer sheet. So we got that y was equal to 518.18 multiplied by 1.272, okay, to the x. So what is the growth rate of the Nasdaq? That looks like it was, if you think about that in terms of percentage, that's 100% plus 27.2%. So we have a 27.2% increase in the value. Okay, so yeah, that's pretty good. So now, in what year will the Nasdaq hit 10,000? And then in 2017, what will the stock index be? So, and again, now that we're starting to get more and more used to this, we're going to go do this really quickly in kind of one step. We're just going to jump to the calculator, do those couple things, and then we'll come back here. Okay, so here we go. Okay, so we have found the regression equation. So now let's go to y equals, and I've deleted the one that was in there before. So to put our new regression equation there, we're going to press vars, number 5 for statistics, and then we're going to go to the EQ and we're going to grab our regression equation, and so there it goes. Then, because my plot one is still turned on, I'm going to press zoom and then number 9 to see a graph of it. So here we go. And the first question is, when will the Nasdaq stock hit 10,000? Okay, so now let's go to y equals, and let's enter in 10,000 here. Now, I'm not sure if my window is going to allow for that, so I'm going to check out my window here. Ooh, my Y max here is only 5,386 here, so I need that to be substantially larger there. So let's make that up to, let's go up to 12,000. That way I know for sure I'm going to see the 10,000. But now I'm a little concerned that my graph doesn't go out far enough. So let's make that, I don't know, let's put that out to well, at least 10. Let's see what happens if I go out to 10. Because it looked like it was growing relatively quickly there at the end. Oh, no, well, not quick enough. Yeah, that's not going to work there. So we got to go out a little bit further here. I don't think we got to go out much further, though. Let's take that out to maybe 15. See what happens when we graph that. It's looking a little quicker. Oh, yeah, that'll work. Okay, and then now there's our 10 coming across there. So second trace, and then we're looking for the intersection. So we're going to number 5. Yes, it's on the first curve. Yes, it's on the second curve. Absolutely, you can guess that. And we get 12.3. Okay, so 12.3 or 12. It's going to be, we're going to round to the nearest value there, so 12. So we'll put that in just a moment here. Then the last question is, in the year 2017, what will the stock index be? Well, okay, for 2017, let's just think about that. What year do we got to plug in here? Well, we are going up by ones, okay? So we are going up by ones here. So if we go 2017 and we subtract that 1992, okay, that's going to end up being 25. So we are looking to enter in 25 into this. Now, again, I don't think my window settings are going to allow for that. My Y max, X max there is only 15. So I want to make that at least 30. Well, at least 25, but 30 gives me a little bit of leeway there. Now, this is going to go up really, really quickly. And then you're going to see it continue to think here because the graph is still going across the screen, even though it's way, way above the screen. That's okay. My answer is going to be above the screen. I don't worry about that. So second trace, I'm interested in what happens when I have a value of 25 in there. Now, maybe because I can't see it, maybe I'm concerned that it's on the wrong one. But if I press the down arrow, there, I can see it on the red one. I don't want that. I want it on the blue one. And that's going to give me a value of, what is that? $212,068.95. Okay, so let's go back and let's enter this little bit of information in our answer sheet and wind up the lesson here. Okay, so grabbing the information that we just found there, we saw that in what year will it do that? Well, it's going to happen here in the 12th year, but what year does that correspond to? Well, that's going to be 2004. I mean, I know that because we got 12 here, but the year 8 here, in the way we were numbering it here, corresponds to the year 2000. So 4 more years up here. And then in the year 2017, remember we discovered that was going to be 25 years later. What will the value of the stock be? Ooh, it's going to be good. $212,068.95. Okay. And there you go. And I hope that gives you a little bit of sense of the rhythm as to how these questions are going to be asked on one hand, and also how you'll answer them.